Have you heard the expression, looking for a needle in a haystack? Well, my project turned out not only to be just that, but differentiating between several different needles within a gigantic haystack. I am studying the ancestral Rocky Mountains of Colorado and adjacent states. This represents a major problem in the geologic record. We don't know how these mountains got there, what tectonic mechanisms collided to produce these mountain uplifts. But what we do know is they formed about 330 to 270 million years ago. These mountains are very important to study because they shed sediments that went on to produce sedimentary layers throughout the Southwest that are rich in natural resources, such as precious groundwater here in the Southwest. So, if we could better understand and constrain the timing and tectonic mechanisms of these mountains, we could help better track the groundwater and subsurface flow of resources such as water underground by just knowing a little bit more about the surface. As a geologist, I thought, okay, how hard could this be? It's a mountain range that's older than the dinosaurs and doesn't exist anymore. That sounds like a lot of fun, right? Well, so I went out to the field, collected rock samples from this area about that age, brought them back to the lab, and thought, okay, let's do radioisotopic dating. Similar to carbon dating, that can tell us how old these rocks are and when they were brought to the surface. Should have been straightforward. However, there were several problems with that. In this region, rocks could have washed in from anywhere. There's an old expression that says, it's not easy being a rock. I may have made that one up, but it's true. Rocks get eroded, they get broken up, they get faulted, they get heated up by volcanoes. So I needed rocks that were close to their mountain source, not heated by volcanoes, and accessible. Therefore, I had to utilize geospatial technologies using the computer program Geographic Information Systems. With this tool, I was able to plot the rocks of this age that we wanted in blue in relation to their mountain root sources in purple to the west and green to the east. Also, I plotted the volcanic rocks that would thermally alter those atomic clocks in pink. This in turn allowed us to effectively remove the hay from that stack and pinpoint just the select few data points we want out of an area of greater than 500,000 square miles over 5 major mountain states. This led us to go to the field, collect the rocks to best understand the ancestral Rockies, which can therefore help us better understand and manage our precious natural resources. Thank you.